the JavaScript-based control software and interface for an Igus joint. I previously wrote this software to control the open source Anon robot, which uses a bunch of stepper motors. You can actually see a box back there. That box was originally designed to control the Anon robot, but right now I have it hooked up to the Igus joint you see down there instead of the Anon robot. That's being powered by a 24-volt power supply, which is in the box, and there are just 4 wires going to the joint right now. There is positive and negative 24-volt going to that, and in addition to that, you have the Raspberry Pi CAN bus going to the joint as well. So the Raspberry Pi has a CAN shield on top of it with 2 CAN interfaces, and what I'm going to do now in the UI is I'm actually going to go and I'm SSH'd into the Raspberry Pi here, and I'm going to go ahead and start up a little JavaScript server. You can see it's sending the state updates to the UI every second. So what we're looking at here is actually a simulator to control a robot that I've designed, but I don't have the actual whole Rebel robot yet. So what I'm going to do is actually just go to the motor controller itself. So in the motor controller, you can see we're currently not connected to anything, but when I drop down this drop down, you can see that I have the option to select a robot. This robot drop down got populated because of the connection from that Raspberry Pi. When I connect, you can see I now have an option to pick a joint. In this case, I only have one, and you can see I'm now getting a readout down here with some information about that joint down there on the desk, including its CAN ID and its encoder position, whether it be the one that's given every second or the one that's given via the position right commands, any sort of error codes, and any sort of parameters I can query for here. So what I'm going to first do is actually going to go ahead and reset this motor, which the motor should then go into the motor not enabled state. And the reason it didn't do that is because I actually forgot to boot up, and I'll do that right now so you can see it. I'm just going to go ahead and bring up the CAN interfaces. So the CAN interface was not up, and that's why it wasn't able to write. So I'm going to go ahead and bring up CAN 1 and CAN 0 and reboot that interface there. And now that the CAN interfaces are up, I should be able to actually call that reset command. And you can see the motor is now in the motor not enabled state. So I'm going to go ahead and enable that motor. The motor is now enabled. And if I tell it to go to 90 degrees, it will spin to 90 degrees. If I tell it to go back to its home, it will go back to its home position. I can also, grab this slider. Let's say I want it to go to 30 degrees. I can use this incrementer to move it by a degree, or I can use this slider to move the joint around as well. I can then go ahead and disable that motor if I want to. And just to see where we're going with this is if I go ahead and reset and enable that motor again, and I were to go over to the robot interface over here and connect to robot 1, you can see that if I move this joint here, it's actually going to move the joint down there. So eventually these sliders, which control this UI right now, will actually control all the joints on the actual robot itself. So that's a little update on this project, and I hope you guys enjoy.